Alright, I just wanted to jump on and talk to you about finite differences because there's been a lot of questions about this problem on the homework. So, what does finite differences mean? There are a couple examples in your book, notably in section 8.2, but I'll just go ahead and do it because I think the book might be kind of confusing. So, let's just take a sequence and our familiar sequence. This is the sequence of the number of toothpicks in an n by n square. This is the activity we did in class on Friday. So 0, 4, 12, 24, 40, 60. So what finite differences means is that I'm going to take the difference between the terms in the sequence. Many of you were already doing this intuitively to try to find the recurrence relation. So here I would take 4 minus 0, and that's 4. That's our first difference of the first two terms. And then I would take 12 minus 4 is 8. 24 minus 12 is 12, and so on. So I get 4, 8, 12, 16, 20. So a lot of you did that on this problem to figure out the recurrence. So that's our first difference. Our second difference is what I get by taking the difference of the first difference. So what I mean by that is I'm going to do 8 minus 4 because 8 is the second term in the first difference and 4 is the first term in the first difference. Okay, and then I do 12 minus 8 is 4, 16 minus 12 is 4, 20 minus 16 is 4. They're all the same. So that question is asking about keep taking the differences until you get a column like this where all the differences are the same. Okay. Now, this isn't always going to happen. That question is telling you that that's going to happen for you. So here's an example. 0, 1, 2, 3, 4, 5, 6. The sequence terms are 1, 2, 4, 8, 16, 32, 64. So you might recognize this sequence in its closed form is 2 to the n. Okay, maybe you didn't, but that's what it is. It doesn't really matter the closed form. What I want to talk about is first differences and second differences. So first differences, that means that I'm going to take the second term minus the first term. So 2 minus 1 is 1. 4 minus 2 is 2. And so forth. 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. 64 minus 32 is 32. Okay? What's interesting about this is that we actually see the exact same sequence popping up again. Okay, let's try the next column. Second differences means I'm going to take the differences between the first differences. So 2 minus 1 is 1, and so on. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. And 32 minus 16 is 16. Okay, again, that same sequence is popping up. If we keep going, we're going to get the exact same thing happening. So in this way, we see a self-similar sequence, which means that these finite differences are never going to end up being constant like the last one was. This one was really special. Oh, that's not what I meant to do. This one was really special in that all the end of all of them became constant. So that's what you're doing, and we'll talk about it in class tomorrow if you have questions.